All right, let's look at the theorem about the Cauchy product. All right, so series AN is absolutely convergent. So here, absolute value of AN with the summation converges to alpha. And also, series AN is convergent without the absolute value sign. And also, series Bn is convergent to B without the absolute value sign. Then Cn is as we defined for Cauchy product. The Cauchy product converges to the product of A and B, right? Which is where it's supposed to go, all right? So let's try to prove that. All right, so let's find the, let's look at the partial sum Cn. So capital AN is just a partial sum for AN, and the capital BN is a partial sum for BN, and the capital Cn is a partial sum for Cn. All right, so and beta n is just the difference between partial sum and actual sum. All right, so let's look at the capital Cn. All right. If you write this guy out, so this is a partial sum of the Cauchy product. So this first term would be A0 times B0, right? And the next term would be A0 times B1 plus A1 times B0, right? And the next one is A0 times B2 plus A1 times B1 and A2 times B0, right? I'll say, so keep on following the same pattern, and the last term would be A0 Bn, and then and so on, and AN and B0. Right? So next thing we do is I'm going to look at the terms that has A0 in it. So I'm going to say, right, here is a 1, A0, B0, A0, B1, and A0, B2, A0, B3, and so on. Then last one is A0, Bn. Right, so if you factor A0 out, so A0 out, you end up getting B0 plus B1 plus B2 all the way to Bn. That's actually just a partial sum, capital Bn. Right, so that's the partial sum there. All right, then next one is look at the term with A1 in it. So A1 B0, A1 B1, A1 B2, and so on. And the last one would be A1 Bn, Bn minus 1. So maybe I should have written that. So here, there's a term A1 Bn minus 1. Alright, so if you factor A1 out, you're going to have B1 plus B2, B0 plus B1 plus all the way to Bn minus 1. So that's just a capital Bn minus 1. Alright, then you can see that this pattern just keeps on going. Then last one is An and the capital B0. Alright, so we have that. Then what we're going to do is we're going to actually rewrite this guy using a beta n so that we can involve the sum b. Right, so I'm going to actually rewrite this guy as solve for capital Bn. Alright, this can be written as capital B plus beta n. Alright, so we put that in. So you have A0, right? So Bn is capital B plus beta n. And the next one is A1 and a capital B plus beta n minus 1. and so on. Then you have an, then you have a capital B plus beta 0. Alright, so looks like we have a bunch of B's, so I'm going to factor out capital B. Then you see that so the A0 times B, A1 times B, A2 times B, and so on, AN times B. So if you factor B out, you're going to have A0 plus A1 plus all the way to AN. That's just a partial sum of A, so we put capital AN. Alright, then you have this remaining term. So this is going to be A0 beta n plus A1 beta n minus 1 all the way to A1 beta 0. Right? Then since capital AN approaches A as n approaches infinity, so we know that this guy right here goes to where we want it to go. So this is going to go to AB, right, which is the sum. All right. Then we want to show that since this goes to where we want to go, we have to show that this guy, the remaining term, is going to basically disappear. So this guy goes to 0. So we have to show that still. All right. So let's prove that this remaining term is going to approach 0 on the next page. Alright, so now we are left to show this sum is going to approach 0 as n approaches infinity. Alright, so remember that beta n is the difference between partial sum bn and the sum b. So of course, since it's a convergent series, this beta n is going to approach 0. Right? Right. So since beta n approaches 0, right? So we know that there exists some big enough n such that n is greater than or equal to capital N, guarantees that absolute value of beta n is going to be less than epsilon. So this is for all epsilon, right? We can do that, all right? So what we're going to do is I'm going to actually write this guy backward, all right? So look at this sum. So we know that A1 times beta 0 plus A2 times beta 2. Beta. Oh, actually, I think I messed this up. This has to be AN. Sorry about that. This is AN. So this is AN. All right. So let's see. I'm gonna erase this guy. All right. So the next term would be AN minus 1 beta 1 and plus and all the way to, right? Let's do AN minus n minus 1, actually plus 1. Then you have a beta n minus 1, right? So I'm going to group those guys together, right? Then plus, right? So the next term would be an minus n, right? So this is going to be beta capital N, and then you just keep on going until the last term is A0 beta n. so we have that. All right, then you can see that, let's see, so A0 beta n. All right, so you can see that here, these terms, we can bind it. The upper bound is going to be, let's see, here. So you have all these terms, an, easier. Actually, I want to look at the absolute value. So we're gonna put the absolute value here. Right. Then here, this is going to be, we can bound these guys pretty easily, because as n goes to infinity, an is going to go to 0. So we have, say, an minus 1, beta 1, and so on. So these guys will have no problem. So I'll just delete that for now. Plus 1, beta, and capital N minus 1. Right, so these these terms right here, right? So I'm gonna split into. So I'm gonna use another triangle inequality. So an minus capital N, and then you have beta n, right? Plus all the way to a0, absolute value of beta n, right? So you can see that here, all these guys we're guaranteed to be, so this guy is less than epsilon, and this guy is less than epsilon, right? Then this is going to be absolute value a0, next one is absolute value of a1, and also all the way to absolute value of n minus capital N. So that's going to be bounded by alpha. So we have, this is, right, all these guys, right, and note that n is fixed, capital N is fixed, right, and this guy is going to be bounded alpha times epsilon, because everyone has epsilon, and the sum of all these guys is cannot exceed alpha, right? Alpha is the sum of the absolute value of an. All right, then as n approaches infinity, right? So we know that this guy right here, and this guy goes to 0, and the next y goes to 0. And for the fixed capital N, this guy also goes to 0. So the whole thing here goes to 0. So we know that the limit, if you look at the limit of absolute value of this sum, a0 beta n plus all the way to an beta 0, right, as n approaches infinity, is going to be less than, right, so these terms disappear, and alpha times epsilon, right? But since epsilon is any positive number, so which means that this has to go to 0. So therefore, here a0 beta n plus all the way to an beta 0. Alright, this guy approaches 0 as n approaches infinity. Alright, this will show that the previous one is going to go to 0. So we know that, so therefore, so actually I'm running out of space, so hence we have summation Cn, and n approaches from 0 to infinity. Right, so Cauchy product is going to approach capital A times capital B, which is what we wanted to show. All right, that's it. I hope that this was clear.